Hello, everyone. We are Group 5 of Human Factors 02 KKI. We'll be presenting about ergonomic design recommendations for the activity of picking up groceries from a car trunk. Our group consists of me, myself, Anan, Rafa, Dafino, Irena, Rifat, and Dandi. In this study, we will use the ergonomic tool, rapid entire body assessment, and rapid entire upper limb assessment in order to analyze body posture and identify potential risk levels associated. These methods evaluate the arms, legs, necks, and posture during the activity and help determine whether corrective actions are necessary. We are in a situation where picking up groceries is a common occurrence in our daily life. It involves bending, reaching, and lifting items from car to the outside of the vehicle. The trunk height is typically below the user's waist level, demanding the users to lean forward while retrieving grocery bags or other items. The problem is that despite its routine, due to awkward body posture during the movement, the need to bend forward and extend the arms into the trunk can increase mechanical load on the lower back, shoulders, and arms. If done repeatedly, it may increase the risk for musculoskeletal disorders or MSDs, particularly in the lumbar region. Due to the potential ergonomic risk, the posture used when picking up groceries from a car trunk must be assessed using methods such as REBA or ruler to determine the level of risk. The results of this assessment can then be used to propose improvements to redesign the car trunk so that it becomes more ergonomic and reduces physical strain during the activity.
To supply the necessary inputs for the rural assessment, which we want to improve the put groceries from the trunk activity. We we use rural assessment, and we need to measure several anatomical joint angles, including arm and wrist analysis, locate wrist position, locate lower arm position, locate neck position, and last is trunk position. While a complete rural assessment typically requires a broader set of data points, the current stage focus on specifically on capturing the activity angles observed from the field documentation, which we have Anan who be the models here, and we determine the angle of the anatomical angles by angles app. And here is the summary of the observation. There's upper arm angles, and so on and so on. Next. So in this rural assessment for Anand's activity, we see there the final rural scores is 6, which the rural assessment shows that the posture used while reaching into the car trunk has a high risk of causing muscle strain. For especially for the lumbar muscle. So the working method should be improved soon. Next.
Okay. Next, I will explain the injuries that may occur during the activity. First is wrist and forearm disorder, which are caused by awkward wrist posture and repetitive gripping, which can increase the risk of carpal tunnel syndrome or CTS. Second is lower back disorder, which are caused by forward bending during lifting activities, which increases spinal loading and contributes to the risk of occupational low back disorders. Third is shoulder disorder, which are caused by repetitive reaching into the trunk, which can strain the shoulder joint and rotator cuff, increasing the risk of shoulder disorders. Lastly is neck strain, which are caused by sustained neck flexion while looking into the trunk, which may increase the risk of neck musculoskeletal disorders.
So we identified the main problem in this activity. When retrieving groceries from a car trunk, users usually need to bend forward and reach deep into the trunk. This posture increases mechanical load on the lower back, shoulders, and arms, which can lead to musculoskeletal disorders. To reduce this ergonomic risk, we propose a sliding trunk platform. This system allows groceries or luggage to slide outward toward the user, reducing excessive bending and long reaching distance. The prototype includes several features such as sliding platform that extend about 70% of the trunk depth, an anti-slip surface, a locking mechanism, a foldable handle, and a load capacity of 40 to 50 kilograms. So overall, this design help reduce trunk bending, lower lumbar strain, and decreases the risk of MSDs.
Next, I'll explain the design details of our sliding trunk platform innovation. The system uses a linkage-based sliding mechanism that allows the platform to move outward from the car trunk. The mechanism consists of three main structural components. First is the base platform, which acts as the main frame mounted inside the trunk and supports the entire structure. Second is the platform support bar, which connects the base platform to the sliding surface and helps maintain stability during extension and retraction. Third is the pivot joints, which enables rotational movement. These joints convert rotational motion into forward sliding motion, allowing the platform to extend smoothly towards the user. In terms of product dimensions, the platform has a width of 830 millimeters and a length of 750 millimeters. The sliding mechanisms allow the platform to extend up to about 70% of the trunk depth, while supporting a load capacity of around 40 to 50 kilograms. Several features improve usability and safety. The design includes a linkage sliding mechanism for smooth movement, an anti-slip platform surface to prevent groceries from sliding, and a foldable ergonomic handle that allows users to easily pull the platform outward. By bringing items closer to the user, the platform reduces trunk bending, shortens reach distance, and improves lifting posture, which helps reduce strain on the lower back.
And from our analysis, we can take away that the initial posture produced a Rula score of 6, indicating a higher ergonomic risk caused by trunk bending and long reach distance. But with the redesigned sliding platform, the score decreased to 4, demonstrating an improved lifting posture and reduced MSD risk.
Based on the ruler assessment and ergonomic analysis, our study identified that retrieving groceries from a car trunk creates a significant ergonomic risk. The initial posture resulted in a ruler score of 6, which indicate a high risk level and requires immediate improvement. From the analysis, we found that several body parts are most affected, particularly lower back, shoulder, wrist, and neck, due to repetitive bending and reaching movement. To address this issue, we propose a sliding trunk platform which allows items in the trunk to slide outward towards the user. This design reduces trunk bending, decreases reach distance, and improves lifting postures. With the redesigning and the ergonomic posture improved and the ruler score decreased from 6 to 4, indicating the lower risk of musculoskeletal disorder. Overall, this solution demonstrates how ergonomic design can effectively reduce physical strain and improve safety during everyday activities.
I think that sums up our presentation, and this is our reference. Thank you for listening.